to actually understand asteroids, you got to see them up close, not just as a dot in a telescope. And so the Galileo spacecraft flew by asteroids on the way to Jupiter. A couple other spacecraft flew by asteroids on the way to other objects. The NEAR spacecraft was originally designed, in fact, to go visit a couple of near-Earth asteroids, and then the Hayabusa spacecraft went by the asteroid Itokawa. But those were all small asteroids. So the question is, what about really big asteroids? Are they any different? Because the small ones, are either leftovers from the formation of the solar system, or they are pieces of bigger ones blown apart by impacts. The bigger ones may, in fact, be planetesimals left over from the growing phase of the solar system. So NASA launches a spacecraft called Dawn spacecraft, launched in 2007, and flew out to the asteroid, flew by Mars, and then spent a year orbiting the asteroid Vesta. And then from there went on for another few years, and then went to the asteroid Ceres, where it's been ever since for the last 5 years. And so Vesta was the first of these bigger things ever seen. And so for Vesta, and you can see here, it's got craters on it. Some of them are soft craters, but they're much more distinct than the craters that we find on the smaller asteroids. And so that suggests this is actually a solid surface on there. Here's Vesta in comparison with those other asteroids. And so you see just how big that Vesta is by comparison. So this is why this is a significant thing. So these all those small asteroids, were all visited. Actually, Lutetia is fairly recent also, but these were the smaller ones that were visited at first, and then Vesta. And it's huge. In fact, it looks mostly round. There's a few protrusions on it. There's cracks and crevices. In fact, the surface is very rich compared to the others. It's almost in hydrostatic equilibrium. Basically, it probably was. Now, hydrostatic equilibrium means gravity pulled it into a round shape. There's a couple of large dents on it, and those large dents on it probably are from impacts. Now, it may have actually pulled itself into a round shape, and then it would have been classified as a dwarf planet. And then things hit it and knocked big chunks off. So this raises another question. Does that actually count as a dwarf planet or not a dwarf planet if you knock chunks of it off? And so it's got these grooves around the middle of it too. Those grooves are probably from the impacts that happened on the ends down here on the south end that made a giant crater right there that actually made it out around. There's evidence that parts of the surface have been resurfaced, volcanic activity of some sort, either molten rock or more likely water. At this distance from the sun, water is mostly frozen, but if you heat it just a little bit, it can come out into the surface, maybe as some kind of slurry or something. So that makes this a much more rich geologic surface. We've got mountains and crevices and cracks and rills and all kind of things you don't normally see on those little small rocks that we saw before. Most likely, when everything came together, the heat of coming together helped melt it some. The really heavy stuff sank to the middle, so that means differentiation. Differentiation means heavy stuff sinking to the middle. Okay, the really heavy stuff would be radioactive material, which made kind of like a radioactive core that was hot. And it probably took tens of millions of years for it to finally cool off so that it was no longer fluid on the inside. During that time, there was some volcanic material extruding out onto the surface. And most likely the interior has been mostly crystallized since then. And then since then, it's been sitting there, and then other asteroids and meteorites hit it, and some of them hit it hard enough to blow chunks of it away. And so it may be actually a pretty altered protoplanet, unaltered protoplanet. Other than a few things running into it, this may be what protoplanets looked like at the very beginning. This huge crater at one end of it, south end, 13 kilometers deep, so it's like 7 miles deep, and with a mountain peak in the middle where the ground rebounded from the impact. turns out there's a whole family of smaller meteorites and asteroids we call V-type asteroids or V-type meteorites that have the same spectrum as the surface of Vesta. And many of them have similar orbits to Vesta. And so we kind of think that they might actually be, that Vesta might be the parent body of these things. So an impact here like this from a smaller object that blew big chunks of it out could have been what caused those V-type asteroids and V-type meteorites that we see. Now we could actually spend a lot more time on Vesta, but we need to cover a lot of other things in the semester. Ceres was the largest of the asteroids. In fact, it is definitely classified as a dwarf planet. It's so big that roughly a third of the whole mass, estimated mass of the asteroid belt is in Vesta, or in Ceres rather. It's still pretty small though. It's smaller than Texas, only about 600 miles across. And so there is the possibility, though, that had Jupiter not moved inwards, that Vesta would have continued growing in size until it may have been the size of Mercury or the Moon. A lot of the other asteroids that were in there got thrown out, and so it could have actually been a reasonably sized object had it been given a chance to grow. The orbit of Ceres is slightly elliptical. It's much more elliptical than, for example, the inner planets, and slightly tilted. Again, that's probably the result of Jupiter moving inwards here and disrupting the orbits of things. Prior to the Dawn spacecraft visiting Ceres, our best view of it was with the Hubble telescope. And this is the picture right here from the Hubble telescope. You can see bright and dark markings on the surface indicating that it's not just a solid rock. There's something to this. It's got some kind of surface features. And so once you get close to it, you notice, well, it actually is interesting. It's definitely spherical. It's got, now here's the really weird part. It doesn't have the sharp craters that Vesta has. They are all these flat bottom smooth craters. Well, what's going on there? The clue is that bright speck right there in that crater. That bright speck turns out to be salty ice. Well, what happened? Well, in almost all likelihood, what happened was similar to Vesta. The heavy stuff sank to the middle and the light stuff came to the top. Except Ceres pulled in more of these icy things, and those icy things then made ice a major component of it. And so the rocky stuff sank to the middle, the icy stuff floated up to the top, and so we probably have a large mantle of ice with dirt and dust on top of it. Now, the impacts of other craters indicate that they probably made craters in the ice. Well, ice flows. Think about glaciers. And so the ice would flow into these craters and smooth them out. These bright specks on here are where some of that ice is shining through a little bit. All this ice actually from the action of the sun can actually sublimate. It doesn't really melt at this temperature, but it will turn directly into a gas, leaving a super thin atmosphere of water vapor surrounding Ceres. Now, by super thin, I mean it's like close to a vacuum, better than a vacuum that we get with a vacuum pump on Earth. So there's barely anything there, but the fact that there was anything is really a little bit of a surprise. Probably shouldn't be because we found thin atmospheres on many different objects, but at first it was a surprise. As I said, the basic idea is we probably have a rocky interior, so an iron nickel core, like many of the large objects do. The heavy stuff sinks to the middle. And then we have a silicate mantle. That's your generic rock type stuff. And then on the outermost part is a layer of ice. And then on top of it is various other sort of things that run into it and have settled onto the surface of it. And so are dust and meteorites and so forth. Now, that makes this a very interesting world because this object has much more dynamic surfaces than some of the others. We got mountain peaks here. The mountains are not really well explained here, whether it's an upwelling or something from below pushing itself up, with like ice flows pushing them up or whatever, or we don't really know. The smooth bottom craters are almost certainly due to ice flow into there. And some places where the dirt and dust on top has been disturbed, you get those white faculae or bright regions there. Also has canyons. The canyons are not like the cracks on some of the other bodies, things that are impact features where you shock it and crack the world. We saw that on Gaspar. We saw that. That's probably what those grooves around the equator of Vesta are. This is not the same thing. These are not oriented in the same way, and they don't seem to be in any particular orientation or anything like that. There's no good explanation for them. The only way you get something like this would be if the ground is trying to move underneath. So that would again suggest some kind of tectonic activity below the surface. Not something at all we expected for a world this small. So while Ceres may be not a major planet, it definitely rocks the whole dwarf planet definition, because it is acting like an entire world with geology and an environment that is unlike the little rocks that we see with the other